Hello, I'm Don MACHHOLZ, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 60 for the week of February 24th, 2021. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, February 24th, the moon is 90% full in our evening sky. On Saturday, February 27th, the moon is full, rising at sunset, up all night, and setting when the sun rises. We will have a full moon weekend. This is also a good time to get out and photograph moonrise in the east during evening twilight. By next Tuesday, March 2nd, the moon will be rising 3 hours after evening twilight, giving us some time to see the evening sky without moon interference. The planet Mars is closing in on the Pleiades, also known as the Seven Sisters, and passes just south of the star cluster on Tuesday and Wednesday, March 2nd and 3rd. In the morning sky, Mercury is approaching Jupiter. They will be closest to each other on March 4th and 5th, with Mercury about 1/3 of a degree north of Jupiter. We'll discuss that again next week. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, February 24th, through Tuesday, March 2nd? It all depends upon your location. This week we have 4 zones. All you need to know is your latitude. At 65 degrees north, you'll not see the International Space Station at all. From 35 degrees to 60 degrees north, you can see the ISS in your morning sky for the whole week, sometimes twice per night. From 25 degrees south to 35 degrees north, and that's most of the populated world, the ISS will not be visible at all this week. South of 25 degrees south, the International Space Station will be in your evening sky for at least part of the week. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. There's no bright comets in our sky this week. Let's talk about time, hours and minutes. Time is important in astronomy. If you told me what time it is where you are listening to the podcast, you merely have to look at a clock or more likely at your cell phone and read me your time. One of the components of that time would be your time zone. There are 24 time zones around the world. Almost all differ by 1 hour from the adjacent time zone. Some differ by 30 minutes, but that is rare. Your clock or cell phone takes that time zone into account when it generates the present time. In astronomy, we sometimes need to record and communicate the moment that an event occurs. Like what? Well, the beginning and ending time for a lunar eclipse, or for a solar eclipse, the time of occultations or conjunctions. All these events and more can be seen from many different time zones. By convention, astronomers use something called universal time. Whenever I discovered a comet and wanted to report it, I had to convert my local time to universal time when I reported it. It is also known as Greenwich Mean Time, or GMT. In military, it is known as Zulu time, and the most recent name is UTC, which stands for Coordinated Universal Time. I know the initials do not add up right, UTC for Coordinated Universal Time. Greenwich is where the Royal Observatory of England is located. Greenwich is in London, England. That is also known as the prime meridian. You can go there and straddle the western eastern hemisphere of the Earth. Similarly, you can go to the equator and straddle the north and southern hemisphere. Where the prime meridian meets the equator in the Atlantic Ocean off the western coast of Africa, you can straddle all four, like the four corners of the Earth. But getting back to the prime meridian, the Earth has a coordinate system known as longitude and latitude. Longitude lines run north and south, and longitude is measured in degrees. 360 degrees go all around the world, but the labels do not number from 0 to 360. Instead, they run from 0 to 180 degrees west from Greenwich, through the Atlantic Ocean, through the Americas, and into the Pacific Ocean. Are you ready for this? The numbers are actually negative numbers. As you go west from Greenwich, the proper degrees are negative. If you live at 75 degrees west, then it can also be written longitude equals minus 75 degrees. At minus 180 degrees, we have something known as the International Date Line. As we cross that line, it becomes the next day. Now the longitude numbers start decreasing from 180 to 0. They are positive, not negative, and are written such as 75 degrees east longitude. They go from 80 to 0 degrees, passing through the rest of the Pacific Ocean, Asia, and then Europe. At Greenwich, 0 degrees east meets 0 degrees west. That is why when New Year begins, it begins in the western Pacific Ocean, moves across Asia, Europe, and 12 hours later, it reaches Greenwich. We are now halfway into the new year. Half the world is in the new year. The other half is still in the old year. Those living in the Americas are among the last to have the new year enter their time zones after nearly the whole world has already arrived. I'm trying to keep this simple as possible, because when astronomers talk about time, it can get quite confusing. Now, a train cannot enter the station all at once. First, the engine arrives, then the many passenger cars, and finally the caboose. So it is the same with time on New Year's Eve. Atomic clocks keep the time. At one time, the sun and stars were used to calculate universal time. That was the job of the Royal Observatory, but now atomic clocks do the work. So how can you determine universal time? One way is to call Greenwich and ask them what time it is there. Or you could memorize how your time zone differs from Greenwich. For the east coast of the United States, the difference is 5 hours. At 2 p.m., at Eastern Standard Time, it is 7 p.m. Universal Time. On the West Coast, the difference for Pacific Standard Time is 8 hours. 2 p.m. PST is 10 p.m. Universal Time. So what happens at, say, 10 p.m. Pacific Standard Time. Well, then it's the next day, 6 a.m. Universal Time in England. Hawaii is 10 hours off. That is 10 hours behind Greenwich. New Zealand is 12 hours different than Greenwich and the next day because now we're in the Eastern Hemisphere. Sydney, Australia is 10 hours ahead of Greenwich, and Perth, Australia is 8 hours ahead. Tokyo, Japan's 9 hours ahead. New Delhi in India is 5.5 hours ahead of Greenwich. Remember that tiny portion of time zones are 30 minutes instead of an hour off. Cairo, Egypt is 2 hours ahead of Greenwich, and Rome, Italy is 1 hour ahead. So let me give you the time of full moon this week in Universal Time. From that, you can calculate when it will be a full moon in your time zone. Full moon is Saturday, February 27th at 8:16. Now that would be a.m. 8:16 in the morning in London. On Saturday, the moon will be full. On the west coast of the United States, that translates to 8 hours earlier, which is 0016, which is just after midnight. 16 minutes after midnight, it will be full moon this Saturday. In Tokyo, in the Eastern Hemisphere, it's 9 hours off in the opposite direction, so we add 9 hours to 8:16 and we get 17:16 on a 24-hour clock, and that translates to 5:16 p.m. Now, can you translate your time zone and what time it is where you live to Universal Time? Astronomers have to do that all the time. My first comet was discovered on September 12, 1978 at 5:16 a.m. Pacific Daylight Time. Now, how do I convert it to Universal Time, which is necessary for me to report it properly? The correction for Standard Time for this time zone is 8 hours, but for Daylight Time it's only 7 hours. So I add 7 hours to 5:16 and I get 12:16 Universal Time. Now the Central Bureau for Astronomical Telegrams wanted it in the decimal of a day. Now a decimal would be anywhere from 0 to 0.999. Noon would be half a day, which is 0.5. Add 16 minutes and we get 0.511. Now, this is how I calculated that last part. The number of minutes in a day is 24 hours times 60 minutes equals 1,440 minutes in a day. A half day is half of that, which is 720 minutes. But I found the comet 16 minutes after that, which is 720 plus 16 is 736. So I found the comet 736 minutes into a day of 1,440 minutes. So I divide the two and I get 0.5111. So the universal time of the discovery was September 12th, 0.511. That's what I reported. And for each comet discovery or comet brightness estimate, I had to do it similarly. Are you still with me? If you want to know the exact universal time, you can tune in to the radio station WWV. You need a specialized radio costing not too much to hear the WWV signals. You can also hear the time over the telephone. The time is not given out over the internet because the delays of the internet will make it inaccurate. So, as you get more involved in astronomy, learn your time zone and the number of hours difference from universal time. Commit it to memory if you reside in the same location for decades. The only change would be when standard time becomes daylight savings time and then back again. I think that is enough about time for now. Next week, I'll discuss another time measurement used by astronomers, It is called Sidereal Time. To recap the podcast, what's coming up this week? The moon is full this weekend. This should make for watching and imaging some good moon rises. Mars is closing in on the Pleiades in the evening sky, and Mercury is approaching Jupiter in the morning sky. This podcast has 2 maps that you can download from my website. One is Podcast 60, Map 1 of the evening sky. The other map is Podcast 60, Map 2, showing the morning sky. You can use these maps, even though you do have a bright moon in the sky, to learn some of the brighter constellations. You have been listening to Looking Up with Don, podcast episode number 60 for February 24th, 2021. I'm Don MACHHOLZ. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ, 2 H's. You can contact me at dontheastronomer@gmail.com. Once again, dontheastronomer, all one word, @gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's up in the sky. I'll discuss sidereal time, which is star time, and we are going to track down an asteroid. Have we talked about asteroids on Looking Up with Don? No, we haven't. Not yet. But next week, I'll discuss asteroids, and we will go out and observe an asteroid that's fairly bright in the eastern sky. All that and more. Thank you for listening. See the sky this week. I'll see you next week.